Hi everyone, Ravi this side. Welcome to EnggAdda. In this video, we are going to discuss about the functional interface of Java 8. In the previous video, we have discussed about the supplier functional interface of Java 8. Here we are going to discuss about the functional interface. Now, first of all, what we are going to do is we are going to discuss about the function and what it is and what is the single abstract method of the function, what input it takes and what its return type. Everything we'll discuss, and then we'll try to go to the IntelliJ where I already have created one application. There we'll try to create one class for the function, and then we'll try to implement the functional interface in the traditional way and override the method inside it, and then see how it is working. After that, we'll move to the lambda expression. With the help of lambda expression, we'll try to implement the function single abstract method, and then we'll see what is the use case of the function in the stream API. So let's discuss that, and let me go to the next slide and tell you something about the function. So the functional interface is a part of Java util function package, which has been introduced since Java 8 to implement the functional programming in Java. It represents a function which takes in one argument and produces a result. Hence, this is functional interface takes in two generic, namely as follow. T denotes the type of input argument and R denotes the return type of the function. So function is a kind of functional interface, and it has a single abstract method. Apply, it takes T as a input argument and its return type is R. Okay. Now, this is about the basic of function. Now, let me try to go to the IntelliJ, and there I will create one application. There I will create one class for the function, like functional interface demo, and then we'll brief you about the function first, and then we'll try to implement the function interface in that class. We'll override the method, and we'll go to the lambda after that, and then we'll see the use case of the stream API. Like use case of the function in the stream API. So let's try to create that class first, and one by one we'll discuss everything. So let's say the class name is functional interface demo. Now, first of all, let me walk you through the function. So if we'll go inside the function, you can see this is a functional interface, and it takes two arguments, T and R. And here you can see it has one single abstract method, apply. Apply takes T as argument, input argument, and it has the return type of R. Okay, so this is how the functional interface is looking like. Others method it has is compose, which is a default method, and then similarly identity. So all others are the default and the static methods. You can see the use case of them, but here we are going to discuss about the apply. Okay, so let me try to go to the class first, and how traditionally we implement the interface, the same thing we are going to do here. So let's say implement function here, and the two argument, let's say we are going to provide is integer and integer. So we are going to input the integer, and we are going to get the integer as a result of the apply method as well. Okay, so that is why we need to provide the integer here. Now we are going to implement the apply method, and in the we have overridden the apply method. Now here you need to do the implementation. So here you can see in the this apply method is taking integer input argument. Let me change the name of this argument. Let's say it is X. Okay, so we are providing one input of integer type to this apply method. Let's say we are returning the 10 into X. Okay, so the return type is also an integer. Now create a main method here, and how we try to call this method, the same way we are going to do here. Okay, so what we'll do, we'll try to create an object of this class, and with this object we are going to call this apply method. So just let me create the object of the class here. Let's say it is demo and equal to new. Now with the help of demo, we are going to call the apply method, and let's say we are providing 20 here, and then the return type would be 200, because it is taking the 20 as an input argument, multiply it with the 10 and then returning it. So what you can do, you can create a variable of integer type, assign those value here in this variable, and then simply print it out. So yeah, it is good. If you run this, you will see the result. So here you can see, okay, we are running something else. Let me try to run this main method, and here you can see the result. We are getting 200. We are inputting this 20 as an input argument to the apply method. It is going to this apply, multiplying this input by 10 and then returning back. Okay, so this is the traditional way of implementing a functional interface, or you can say any interface, and overriding the method inside it, which is a abstract method. Now how we can utilize the Java 8 features like lambda expression to implement this single abstract method. So in the previous video also I have discussed about this thing. So if you're going to implement a single abstract method of the functional interface with the lambda expression, then what you need to do, first of all, you need to convert that single abstract method in the form of anonymous function. Okay, and then you can provide the lambda expression and then lambda body, and in the body you can do the implementation. So the same thing we are going to do here. So let me try to comment this piece of code, and what I'm going to do is, here you can see we have the method. Let me try to comment it out as well, and just remove this piece of code. And if you go to the function, this is the method. So copy this method, come here to this class, go to the main method and put it here. Now you need to convert this method in the form of anonymous function. So what is anonymous function? The anonymous function is a function without any name and any return type or any modifier. So remove everything from this single stack method and make it an anonymous function. So we are removing the name and the return type. Now it has a input of type T. So the type you can remove, and let's say it has one input. Now you need to provide the lambda and then the lambda body. So in the body you can do the implementation. So let's say we are going to return something. Let's say we are going to multiply the input by 100 this time, and we are returning it. So the input is T. We are multiplying it by 100 and then returning it. Okay, the spelling of return is return. Okay, yeah. Now what we need to do, we need to create a reference of the function and assign this implementation or assign this whole lambda expression to this function reference. So create a function, and let's say both of the argument are of integer type, and let's say the function reference name is function, and we are good. Now with the help of this function reference that we have created, we can directly call the apply method, and in the method we can pass the value that we want to pass. So let's say we want to pass 30 this time. So what it will do, when we are passing 30 here, it will go to the implementation of this class, of this single stack method, and here we have the implementation. In the implementation, what we are doing, we are multiplying that input argument by 100. So the result would be 3000, right? So let me try to catch the result in a variable, and then print that variable here. So Yeah, we are good. Now run this and then see the result. So here you can see we are getting the 3000. So now again, if you want to minimize this piece of code, you can do, because it has only a single line of a statement. So what you can do, you can remove this lambda body. So remove the lambda body, and also you need to remove the return here. And yeah, and because it has only one input argument, you can remove the braces as well. So just remove that and you're good. Now if you run this, you will get the same result. You can see 3000. So everything is working fine, and this is how lambda expression help us to avoid the boilerplate of code. Now we are working good, right? So what we have discussed about how traditionally we can implement the functional interface and override its method. And then we move to the lambda expression, which is introduced in Java 8. And the lambda expression help us in minimizing the code and writing the very concise code. Now the term stream API. So we'll see what is the use case of the functional interface in the stream API. Okay, so one of the use cases we will discuss, and then we'll wrap up this video. So what we are going to do here is we are going to create a list of integers. We'll convert that list in the form of a stream, and then we'll see the use case of the function in the intermediate methods of the stream API. So one of the methods that take function is map. So we are going to discuss map here. So let me try to do that. So what we are going to do is we are going to create a list of integer first. So just create a list of integer, and let's say its name is L, and we are going to use this array.asList. Let me provide couple of integers here. Okay, 1 to 6. Import the arrays and the list as well. So we have created one array list, or you can say list of integers. Okay, now what we are going to do is we are going to convert this list in the form of a stream, and then the stream has a map function, and you can see this map method is taking function as an argument. So if we'll go to the map, let me try to go inside it and then show you. If we'll go inside the map, you can see it is taking function as an input argument, and its return type is a stream. So now what I'm going to do, I'm going to call this map, and in the map we are passing this function that we have created. Okay, and then see the result. So function, and then what we are going to do, we are going to call the for each, and in the for each we are basically going to print each element of the list one by one. So system dot out, and we are using the method reference here, so println. In the coming videos I will discuss about the method reference, so don't worry about that. So what we are doing is we have created one list of integer. It has the value 1 to 6, and we are converting that list in the form of a stream. Then we are calling the map function. In the map function we are passing this function, and then we are printing each element one by one. So what this function is doing, it is taking out the input, and it is multiplying that input by 100 and then returning as a result. So what will happen here is, let's say we are passing 1 as a input of this function, and it will go to that apply method of the function, and then in the implementation of the apply method, what we have, we are multiplying each element by 100. So the first one will be 100 into 1, which is 100, and then second one will be 100 into 2, which is 200. Similarly, we have the 100 to 600 result. Okay, so let me try to run this and then see. Here you can see the first one is coming from this. If you want to avoid it, you can comment it out. And then afterwards, what we have 100, 200 to till 600. Let me try to rerun this and then show you the result. So you can see from 100 to 600. So what is happening here is we have created a list and then we are converting that list in the form of a stream, calling the map function. Inside the map, we are passing this function as an argument, and what it is doing is it is calling the apply method of the function. Inside that apply method, we are passing each element of the list one by one. What apply method is doing here is it is multiplying that element by 100, and then we are passing we are calling the for each, and it is printing each element after that. So that is what we are getting here in the result. Now what you can do, you can directly pass this lambda expression to this map, okay, and then you can get the result. So if you want to run this, or we run this again and then see. Okay, so let me try to rerun this. I have opted some other option, I think. Yeah, run this and then see. You can see the result: 100, 200, 300, 400, 500 and 600. So this is how the function is working, and we have discussed about one of the use case of the function in the Stream API as well. If you want to discuss, if you want to practice, you can practice the other intermediate method of the Stream API where it takes the function. So you can go there and try to implement it. So this is about the functional interface and apply method. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.